Good afternoon, everybody. Chris F.E. Jackson here. Just perusing some information for tomorrow night's fling out, and came across www.eso.org. Now this is ESO.org, or Echo Sierra Oscar.org, and I found this lovely little video revealing galactic secrets under the subheading of light, and these videos are viewable on the website. ESO is an organization. It's a European organization, but they have a host country in Chile, and these guys have actually fired lasers into the sky about 90 kilometers up, but a bit more of that tomorrow, to be honest. But this little video here details the gravitational waves in forms of light. They've seen it with light. Now, all the research into gravitational waves, we never once heard light being mentioned. There was two neutron stars colliding. Perhaps they meant that. But this video is about 3 minutes long, or if that, so I'll just delightfully play this for you. Lasers revealing galactic secrets. Wow. So the VLT Survey Telescope has captured the most detailed image yet of the galaxy NGC 1316 and its rich surroundings. Well, that's through the atmosphere, right? What about Hubble? That's outside of the atmosphere, isn't it? Or it's about 300 miles up, past the Kármán line. So I would have thought the Hubble would have captured the most detailed images. Oh dear, I've got the wrong video. Can you believe that? I'm awfully sorry. Oh dear. Resume. Awfully sorry about that. Here we go. Telescopes observe first light from gravitational wave source.
Counterpart to gravitational waves for the first time.
For the first time.
A kilonova from merging neutron stars.
Can you see the two stars there? They're very clear, aren't they? They're very clear. Very clear. First light from gravitational wave.
2017.
Oh, look at this. Now, this obviously is an artist's impression of the gravitational light waves. They sort of contoured them. So I wonder why the gravitational waves are only in 2D. This is obviously an artist's impression of what's happening from here, but why the deformation in the lines of gravitational waves? Why would they not be 360? Or why what's affecting the gravitational wave here in the fabric of space-time continuum? Or maybe this is how the fabric of space-time continuum actually looks. Well, I mean, they must have plotted this out with those super telescopes. I mean, this looks amazing.
Detected gravitational waves rippling through the fabric of space-time.
Yes.
Just 2 seconds later,
What?
2 space telescopes from ESA and NASA.
What? Sorry, just 2 seconds later? Wow, they were quick.
Also detected a short gamma ray burst coming from the same area of the sky.
Same area of the sky? What about depth? What about how far away it is? It's just the same part of the sky. That's okay then.
This coincidence had never been seen before.
No, this coincidence had never been seen before. It's a coincidence. Right.
And raised hopes that astronomers had witnessed a cataclysmic event.
Let's talk about hope. How do we determine hope? Yes, today I'm going to undertake a scientific experiment, and I hope it works. I hope the results will work for me.
2 neutron stars combining in an explosive merger.
Look at that.
If so,
If so? You just said they did. If so?
visible light counterpart, known as a kilonova, was expected to follow. The hunt was on.
Yes. I bet they found it.
ESO and ESO partnered telescopes in Chile joined other observatories to search for a new light source. They were looking for a needle in a haystack, a faint new glimmer amid millions of stars.
Yes.
But amazingly, they found it
Amazingly, they found it. I reckon Brian Cox wrote this script. Amazingly, they found it.
a few hours later.
A few hours later.
Galaxy NGC 4993.
Lovely.
130 million light years from Earth.
Right. It's 130 million. Oh, that's the 2 neutron stars, not the 2 black holes. Let's make that distinction very clear. This is only 130. It's a tenth of the distance of the 2 black holes. But, okay, just an observation. I was hoping to get that in.
Over the next few weeks, astronomers used a host of ESO telescopes with more than 10 different instruments to record the kilonova. Neutron star mergers are the furnaces where most of the chemical elements heavier than iron are forged.
Which one?
The kilonova, an event 1,000 times brighter than a typical nova,
Right.
spreads the newly formed elements into the surrounding space.
Newly formed elements. Is that elements as in new, undiscovered, or elements that didn't exist before but now do?
These include the gold in jewellery,
Right.
the platinum in catalytic converters in cars, and uranium
Well, okay.
in nuclear reactors.
Wow.
Such an explosion had never been confirmed before,
Really?
but now one could be studied in great detail.
Yes.
The ESO observations revealed an extraordinary and rapidly changing event, closely mirroring theory.
Oh, this is like gold dust. Closely mirroring theory. Would you not say, proving theory? So it is now fact? So it is mirroring theory. Not sure I like that.
Heavy radioactive elements were shot into space at 1/5 of the speed of light.
Right.
In
Oh.
just a matter of days,
Oh,
the kilonova's colour changed rapidly from blue to red. Fast.
it changed rapidly from blue to red. So that's brightness and wavelength here. So, would that mean it was coming towards us and now it's going away? As in redshift? Or are you actually detecting, as you say, elements in the wavelength of the light? So is that countering the effects of the redshift out in the universe that you detect? I'm a bit confused now. Bit confused. It's not hard, I know, but here we go.
Faster than any other observed stellar explosion. Thanks to the rapid reaction of groups of skilled scientists and ESO's very wide array of instruments,
And hope.
this kilonova was located and studied across a swathe of wavelengths in a matter of days.
Wow.
This event marks the start of a new era of multi-messenger astronomy.
Or make a note of that, people. Multi-messenger astronomy. MMAs, perhaps? Is that going to be a new fad? In terms of astronomical snippets and delights?
For the first time in history, we can now combine light signals with gravitational waves.
Oh, Oh, that's just what? First time in history. Oh, thank the heavens for ESO.
To provide a totally new way to probe the universe.
More to come. More to come, people. Yes, bite-sized astronomy. ESO. Reaching new heights. Well, reaching new shites in astronomy. Thank you very much. There you go. Take a gander at that if you like. Lots of people. Lots of people. Okay, well, I hope you enjoyed that as much as I didn't.